All right, this question's asking us to firstly determine the Cartesian equation and then sketch the locus of points defined by the argument of z minus 1 plus I is equal to negative pi on 4. Now, when we see an equation that has this form arg of z minus something, we need to be able to recognize that this is a ray, so it's a linear function that has a fixed starting point and it only has an arrow on one side. Okay, so our form for these is actually going to be arg of z minus alpha is equal to some angle theta. So this is going to tell us that this thing is a ray. And so what we've got here is we've got the argument of z minus 1 minus I is equal to negative pi on 4. So that means that my starting point for my ray is going to be at the point that this complex number sits. So that's going to be at 1 and negative 1. Okay. And then the angle is going to be clockwise because it's negative pi on 4 to the x-axis. Okay, so that kind of tells us where this thing is, but they also want us to find the Cartesian equation. Now, in order to do that, we need to turn it into something we recognize. So we follow our process. So we're going to let z equal x plus yi. So then what we've got is we've got that the argument of x plus yi minus 1 plus I must be equal to negative pi on 4. And let's collect our real and imaginary components. So we have the argument of x minus 1 plus y plus 1 I. Okay, that still doesn't really look like what we need it to look like. However, we also happen to know that the argument is also the inverse tan of y over x. So we know that the argument of z is also equal to inverse tan of y over x, or our imaginary component over our real component. So that's going to be the inverse tan of y plus 1 over x minus 1. And we know that that has to now equal negative pi on 4. Now, what's important here is as soon as we have a number in our denominator, we need to define our domain. Because if our denominator is 0 or negative, we're not going to get the answer we're looking for. Okay, so we want to be saying here that x has to be greater than 1, and that's a really important thing to be writing on there. Okay, so this means that tan of negative pi on 4 has to equal y plus 1 over x minus 1. And this looks a little bit like methods, where tan of negative pi on 4, we're talking about our fourth quadrant, and tan is negative in quadrant 4. So that means that negative tan of pi on 4 has to equal y plus 1 over x minus 1, and tan of pi on 4 is just 1, so negative 1 is y plus 1 over x minus 1. I can cross multiply over there, so I get negative x plus 1 is y plus 1, and my plus 1's cancel, and I get that y equals negative x, as long as x is greater than 1. All right, so what does this look like? Well, we know that it starts at 1, -1. And we're going to, let's draw in a horizontal axis over here. And we know that it's going at 45 degrees, which makes sense because pi on 4, 45 degrees, and the line y equals -x also goes at 45 degrees. Started at the wrong place. So I have a line that is doing, or array that is doing that. So there I have z is the argument of z minus 1 plus I is -pi on 4.